Okay, here we go. All right, so let's talk about standard units versus what you've been using in lab so it doesn't confuse you. And I'm just going to hit the big ones. When we talk about mass, when we're in the lab, when you put something on that scale, what's it reading it in? Grams. So when we're in lab, our standard unit is grams, or what we use is grams. The standard unit, which is like what they base everything else on when you're talking about measurements in the metric system, it's like, you know, they keep the gold bar that is exactly 1 kilogram. So standard unit is kilogram. What we use in lab when we're actually working is grams. Sometimes we have to convert our grams to kilograms, but our standard is kilograms, our lab unit is grams. So then we'll look at length. This is a nice one because both the lab and the standard I got too many letters in there. Standard for both of those is meters. Unless I have a liquid, well, now we'll wait for that. So mass is grams, standard unit kilograms. Length for both of them is meters. And then, oh, we need to talk about time. It's a nice one because both lab and standard, you know what that is?
Seconds.
Seconds, good, is seconds. And then the last one that we have to worry about standards with is, at least in chemistry for right now, is volume. In our lab, what do we usually measure volume in? Think about that, the graduated cylinders and stuff. Milliliters, good. My standard would be like if you're going to, your mom sends you to the grocery and says, get some Coke. How do you buy that? Normally. Yeah, like in a 2 liter. So our standard is liters. That's how it's normally measured. So that's standard versus lab units. So it doesn't confuse you. Now I think there were a couple of other questions on the yesterday's review that we talked about in lab, but I did have a couple people come and ask questions about them. So let's think about that for just a minute. Find on your review the one that asks you about, I think it's standard density of water or something like that. Yeah, what number is that, you guys? 12. Number 12. Read me, Addie, read me exactly what number 12 says.
What is the density of water at room temperature?
Yep. This is something you guys need to commit to memory. Density of water at room temp.
What is room temp?
What is room temp? It's about 70 degrees Fahrenheit, which is, I'm going to let you figure out what that is in Celsius in just a little bit.
Right.
Anybody remember that from lab when you did that lab and we actually had pure water that I had just put a little food coloring in way early in the year? Carter? Yes, it is. 1 gram per milliliter. Always. That's what we always use. That is a standard. You need to get that in your brain. That's one of those things, just like if I said this, 1 milliliter equals how many centimeters cubed? 1. It's a 1-to-1 relationship. You've got to remember that. Every year people miss that or forget it. So don't let that get you. If you're given centimeters cubed and you're asked to compare it to something in liters or kiloliters, the first thing you can do is change that to milliliters and then make your conversion. I had a lot of people miss that on the last test. Then I think there's a question that says, and this was just really a thought question for you to see if you could figure it out. I don't know what number it is. It asks you about what generally happens to something when it's heated, the density of something when heated? Find that question. 13. Now, Faith, if I'm going to take some water and I'm going to put it on the stove and I'm going to boil it, what happens to the water?
It'll evaporate.
It'll evaporate. What will it turn to?
Vapor.
A vapor, steam, right? Whatever you want to call it. What happens when something turns to a gas? Does it get closer together or does it spread out? It spreads out. So generally speaking, when I heat something, volume does what? It goes up. It increases. Now let's look at this. If I have this formula, D equals M over V, and this number stays the same, and this number goes up, so now I'm dividing by a bigger number. My mass stayed the same, but I'm dividing by a bigger number. What happens to the density? It'll decrease. So density goes down. So normally, a gas is the least dense. Does that make sense? Because it takes up more space. So normally gas is less dense. Everybody done with this one? What do you think would be true then if I talk about a solid? What's normally true about a solid compared to a gas or a liquid? Yeah, normally a solid is more dense. That is the normal. That is the standard. Now here's my challenge. Think of something, think of a substance where that's not true. Addie, what you got?
Ice.
Yay! Ice. What happens to ice when I put it in water? It floats. When something floats, that tells you it's less dense than whatever it's floating in. So ice breaks the rules. Water vapor is still the least dense, but ice is actually less dense than liquid water. That's a rare occurrence, and later on we'll learn it's because of the way its molecules attach when they're in solid form. They actually spread out. But so most of the time, liquid's most dense. Our only example we're going to talk about right now where that doesn't work, I just said liquid, didn't I? Most of the time, solid is most dense. In this case, ice as a solid is actually less dense than a liquid. Then I only have one other thing that I want to show you today, and it has to do with temperature, and it's very easy. Standard for temperature versus lab, what we use in lab. Anybody know what the standard unit for temperature is? Faith?
Fahrenheit.
Ooh, no, we don't use Fahrenheit in science, actually. It's what we use in the United States, so you're not completely wrong. But when we're talking about science, there are two temperatures that we work with. Give me one of them, Carter. Kelvin, that's my standard. This is the scale that has something called absolute zero. And that was one of your vocab words, and I think I had to write something in on every paper as I graded it, which remind me when we get done I need to give papers back. Absolute zero is where all particle motion stops. Now, that's a theory. It's theoretical. We haven't quite gotten that cold in the lab yet. I haven't quite achieved it, but they are pretty darn close. What that means is even a solid, normally the particles in a solid vibrate about a fixed position. When we get things to absolute zero, absolutely nothing moves. They no longer vibrate about a fixed position. That's theoretical. We believe it to be true. We're really close to like achieving that. How about in the lab? What's the temperature we use in the lab? Like if I said go over there by the windowsill and get one of those thermometers. There's a whole rack of them over there. What do you think, Josh?
Celsius.
Celsius. So we will use Celsius. Later this year, we need to be able to convert between Kelvin and degrees Celsius. Kelvin is the only temperature scale that doesn't use that little degree sign. It just gets the capital K. So when I look at that, I can say that Kelvin is equal to degrees Celsius plus, and we're just going to use 273 because it's easier to remember. It's actually 273.15. But if you have a Kelvin, or I'm sorry, if you have a Celsius temperature and it says convert this to Kelvin, all you have to do is add 273 degrees. If you have a Celsius temp, or you want to find a Celsius temperature and you have a Kelvin temperature, then it's K minus 273. Pretty easy stuff. But we just have to, that you need to commit to memory. Like I'm not going to give that to you on the quiz, whatever, you just need to know it. All right, is there anything else on that paper we need to talk about? I think there might be one more thing. About inverse and direct proportion?
Yeah.
Okay.
9 and 8 or 9 and 10.
Okay.
I have both those.
So if I have an inverse relationship, it means when one variable goes up, the other goes down. When one variable goes up, the other one goes down. So let's use this density thing again to talk about that. And let's compare you just told me this. Let's compare density versus volume. You really have to think about it. If my volume goes up, my volume goes up, I'm dividing by a bigger number. What happens to my density? You just told me a couple minutes ago. It decreases, it goes down. So when volume goes up, density goes down. That equals an inverse relationship. You see those in math sometimes in linear equations. You can figure out what the relationships are. Have you done that yet? You look at me like you don't even have a clue what I'm talking about. Okay, you'll hear it later then. So inverse, one variable goes up, the other one goes down. So what do you think a direct relationship is? Good. So let's write that down really quick so you've got it. So direct relationship, when one variable goes up, the other one goes up. I want you all by yourself to think about this for a minute and see if you can tell me the two variables in that formula that are directly related or directly proportional is another way it would be said. Just so that doesn't confuse you. Which two variables in that equation are directly proportional? What do you think?
Mass and density.
Mass and density, good. If mass goes up, volume, remember that the other variable has to stay the same for this to work. You gotta have one constant. If mass goes up, excellent. Density goes up. Okay? Any other questions off that paper we need to talk about? I think I hit them all. Okay. Let me think about this for a minute. There was something else I wanted to ask you guys. I think we got them all. Okay. So